Hello, and welcome to the 11th session of Business Mathematics, where we're taking a look at decision making and uncertainty, or what we call probabilities. By the end of this session, we should be able to understand the rules of probability and how to assign or determine probability for each possible outcome of an event. Secondly, we'll look at how to understand the concept of random variables, where we'll look at discrete random variables and continuous random variables and probability distribution. Understand and calculate the expectation, mean or average of a random variable. Understand and also calculate what is called standard deviation and the coefficient of variation of a random variable. And what role does the coefficient of variation play in a business sense or perspective, right? On our next slide here, we're looking at the introduction to probability. What would you say probability is? Probability gives a measure of uncertainty, right? How likely an event is supposed to occur. What is the likelihood of an event occurring? So we would say that probability is the likelihood or possibility of an event occurring, right? Most times, one would have to make a decision before observing the outcome. One, for example, invest in a business today, you may either attain what? A profit or loss on the business at the end of the period. So when you make plans for electricity demand or generation capacity today in anticipation of next year's demand, right? You don't know. So you want to make a decision on that. Right? You want to plan for next year's demand on electricity. Either you are going to use the same watts or you use more than that or lesser than that, which is also uncertain, right? Okay, when we also toss a coin, the results uncertain and it could be that you obtain a head or a tail, right? So there is some level of uncertainty surrounding the outcome of each of these examples. The uncertainty makes what the decision process challenging. How can one make decisions better in such an uncertain environment? This is done with the help of what? Probability. So probability gives a measure of uncertainty, right? That is, probability of an event is a measure of its likelihood or chance of its occurrence, right? That is probability. So if you toss a coin, you could either get a head or a tail. If it has to do with a football match, you have three possible outcomes. There could be a win, there could be a draw or a lose, right? So that is what probability is trying to say. There could be a 50-50 chance. There could be a 30-40 chance, depending on the number of outcomes, right? So this is a statistical experiment on probability, which is saying that a statistical experiment can be described as any situation specifically set up or occurring naturally. Right. So all statistical experiments have three things in common. One, the experiment can have more than one possible outcomes, probably, right, depending on the event. Each possible outcome can be specified in advance, right? And then the third one is the outcome of an event, of an experiment, depends on the chance. Example, when you toss a dice, right, the possible outcome is you get one, you get two, three, four, five, six. These are the possible outcomes, right? And after the experiment is performed, only one of the possible outcomes will occur, irrespective of the prior probabilities or chances of that event, right? So the probability of one occurring here is just 1/6. So that will take us to how to calculate or find your probability, right? Okay, so let's look at this one too. The outcomes of an experiment. An outcome of an experiment is the specification of all possible distinct results. That is the outcomes, right? That is the outcomes of the experiment when it is performed. So when we toss a coin, the outcome sets or the possible outcomes are just head or tail. You either obtain a head or you obtain a tail. So after tossing this, however, only head or tail can occur and not both will be realized, right? So it's simply telling you that when it comes to probability, right, depending on the outcomes you have, it's just one that could okay. So if you toss a coin like this, it could either get a head or a tail. That's what it's basically trying to say. Same applies to when you toss a dice. You have six possible outcomes. When you play a lottery, you either would win or lose. Playing soccer, there could be a win, draw, or lose. Right. So this is what probability is all about, right? We could either determine the weather condition based on the cloud or how the weather is. We can determine that oh this weather then the probability that it will be sunny is higher than the probability that it could rain. Right? These are possible outcomes that we can also consider under probabilities. Right. Let's move on to our next slide here, where we're still talking about statistical event next from the statistical experiment. So an event is a subset of a given outcome set of an experiment that is of interest. Thus, after performing the experiment, the event may or may not what? Okay. So example, suppose the experiment is tossing a die, right? Tossing a dice. The outcome is just six possible outcomes. What are the chances that two or three might show up? Right. So it is the even set is what two, and then you have three here. So it is just the probability that two or three might occur is just saying that it's two out of the total number of outcomes, which is six. If it's probability that three is occurring, it's just the three here can occur once, right? Over the total number of those outcomes. So mutually exclusive event. Two events of the same experiment are mutually exclusive if their respective events sets do not overlap. In other words, they are trying to say that mutually exclusive events are just talking about the fact that even so when an event one occurs, say you have two events, right? When event one occurs, event two cannot occur, right? It is not dependent on the other, right? So if event one occurs, event two cannot occur, or if event two occurs, event one cannot also occur. That is what mutually exclusive events mean, right? So we have what is called independent events and their probabilities. Two events, say A and B, are independent if the outcome of one, right, of one of the events in no ways affects the outcome of the occurrence or not, right? So this has to do with independent, right? So if this one occurs, that doesn't necessarily mean that the other one cannot occur, right? So they are saying that for that one, the effects of the outcome or the occurrence or not of the other. So if the outcome of one of the events in no way affects the other outcome, they are called independent events. But situations whereby if one occurs, it is possible that the other one will not occur. So if this occurs, this one will not occur. They are called mutually exclusive events. They are dependent. If this occurs, the other one will not occur. Right. How do we measure probabilities or how do we estimate probabilities? It is just by finding the number of ways or the number of times that the probability, a number of times the event could occur over the total number of outcomes. The total number of, the total number of times the event could occur or the number of times the event could occur over the total number of outcomes. So we would say the number of ways or the times event E can occur in experiments over the number of possible outcomes of the experiment, right? Let's look at a practical question here on how to estimate or calculate or measure probabilities. So, example here says the economy of Ghana has always been excellent, good, okay, or bad. The following table is a breakdown of the number of times the economy was either excellent or good, okay, or bad in the last 50 years. So here in the table, you have two columns for the economy with a list of occurrences and then the number of times they occur. So the number of times for excellent 5, good 25, okay 10, bad is 10. Total summation here is 50. What is the probability that next year the economy will be excellent, good, okay, or bad? How do you do that? You find the probability of the economy being excellent. And how do you find it? The number of times excellent is going to occur over the total number of outcome of 50. So for excellent, it is going to be 5 over 50, and then it runs through, right? Good, 25 over 50, okay, 10 over 50, bad, 10 over 50, and that gives you the probability of these respective economy conditions, right? So here we would see that the number of times excellence occurs over the number of possible occurrences or outcomes. So here, excellence, we say it is 5, right? Over the total, which is 50, gives us a probability of 0.1. And then same for good, 25 over 50, 0.5. Okay, 10 over 50 is 0.2. And the probability for bad occurring, the number of times is 10 over the total 50, that give us 0.2. Right. That is how you calculate or estimate probabilities here. Probability is equal to 0. It means that the event will never occur. It is equal to 0. Right. If probability is equal to 1, it means that the event will surely or always occur. There's a probability here that the event will surely occur. Right. If the probability is between 0 and 1, it measures the likelihood. Right. It measures the likelihood. It measures the uncertainty of the chances that the event will occur. Probability can never be outside the range of 0 to 1, right? So note this, there's a golden rule under probabilities. It says that all probabilities must sum up to 1. So then we can find any other probability given one probability. Say we had a probability of one losing a lottery game as 0.5, that is 0.5. Then the probability of the person winning a lottery game is 0.5. How do you find it? Or how do you calculate this? The probability of the person losing is 0.5. Then we'll say the probability of the person winning is 1 minus 0.5. And that will give us 0.5. Right. Look at our next slide here. On next slide, we have a basic example, which is also under the estimating of probability. Below is a table of ages of students attending the summer camp. If a student is randomly picked from a darkened room containing all students, what are the chances that the student picked is age 25 to 29? So these are the ages of the student: 10, 14, 15, 19, 20, 24, 25 to 29, 30 to 34. And then the frequency or the number of times it occurs or they are present, right? So they're asking us to calculate that of 25 to 29. So 25 to 29 here, the number of times that it occurs is 2. Then what do? You divide by the total number of occurrences by adding all the occurrences, and that should give you 20. That is 2 over 20 gives us 0.1 or 0.1. I hope we all get this very clear, right? Any understanding has been enhanced. Right, let's continue. Move on to our next slide, where we have to do with what is called rules of probability. Right. So these are rules that you can basically read on and then get better understanding. So I'll touch on a few and then we'll move on. Right. So addition rule is just telling you that how do you find a probability when you are being told to find a probability between two events or two outcomes. Say probability toss and dice, you know the probability of one occurring is 1 out of 6. So I can ask you to calculate the probability that 1 and 2 will occur. You use the addition rule. The probability that 1 and 2 will occur is the addition rule. 1 or 2 will occur. You use the multiplication rule. The complement rule is just saying that 1 minus the other probability gives you the other probability. So if you have a probability of a person winning a lottery like I gave earlier, say it will take the probability of the person to win the lottery is 0.5. We could say the complement or the other probability of the person winning the lottery is 1 minus zero point 0.5, and that will give us 0.5, right? That is just about it. So in all, given the outcome sets x1, x2, x3, x4 to xn with their respective probabilities, yeah, the following must hold for probabilities, right? So it is just telling you that all probabilities must sum up to 1. So given an event E with probability P, so for the given probability, it is what? 1 minus the other probability. That's for the event E. So if you have one probability, you can find the other by just doing 1 minus that probability, and it gives you the probability for the other. So note that the rules will be covered in depth when you're doing quantitative methods in your previous years in the university, right? Okay. In your subsequent years, sorry, in the university, sorry. Okay, so let's move on to the next slide where we have what is called random variable. What's a random variable? Random variable usually written xi is a variable whose possible values are numerical outcome of a random phenomenon. And so mathematically, sorry, a random variable is represented by a value or the alphabet x. Mathematically represent random variable with x to show that this is a random variable. We have two types of random variable. Discrete random variable. They are random variables that may take only countable numbers of distinct values, say natural numbers 1, 2, 3, 4, or to say 10, right? It doesn't have anything like decimals or fractions. You say that if a random variable can take only finite numbers of distinct values, then it must be discrete. And the second one is continuous random variable. A random variable which can take one infinite numbers of possible values. So the continuous random variable are usually measurements like height, width, pressure, and etc. So basically, this continuous random variable takes both the natural numbers, fractions, and then decimal, right? Okay. What is probability distribution? That will be the next thing to talk about. Probability distribution of random variable describes the chances of the occurrence of possible outcomes of the random variable. That is probability distribution. So that is a list for each outcome, the probability of occurrence. So if you toss a die, the outcome is what? Can obtain 1, 2, 3, all the way to 6. So the possible outcomes here is 6. So the probability that 1 will occur is 1 out of 6. 2, same. 3, 1 out of 6, the same thing here. That is called probability distribution. Now let's take a practical example that will help us to estimate our mean or expected value using some given some information or given some random variables and their respective probabilities, right? So here we have a table here that shows the random variables for the respective electricity demand for next year and their corresponding probabilities. So from random variable x1 to x4, we have our demand here, that is electricity demand in watts. 1800 for x1, 2200 for x2, 2500 for x3, 2800 for 2800 for x4, that is random variable 4, and then for the fifth one is 3000 with their respective probabilities. Here is just a graph to show how this is going to be presented on the graph. Here we have the probabilities here on the y-axis. We have the demand here for electricity on the x-axis. So let's see. Both the table and the graph depicts the same information. The probability distribution of electricity for next year. The demand next year is uncertain among these 5 events. A demand of 2,500 is highly probable, and a demand of 300 is least probable. So I can basically explain or say that based on this, I'll pick this and explain. Say x1, we are doing it for a town in Kumasi. So the community is demanding for electricity 1,800 watts for the next year. The probability that they would either use probability that they will just demand for 1,800 is 0.2. That means that the probability of this community in Kumasi or this town in Kumasi demanding more than 1,800 megawatts or less than 1,800 megawatts is 1 minus this 0.2 probability here. That will give us 0.8. So the probability that this community X1 will use more than this 1,800 or less than this 1,800 is 0.8. Right. I hope you can see that. So let's look at this. Given a random variable x1, x2, all the way to xn with their respective probabilities, the expectation or mean of random variable is giving us. So how do you find our mean or expected value given some random variables and their respective probabilities? Would say is a summation as I goes from 1 to n, right? Is the probability, your probability, respective probabilities times their corresponding random variables. Probability of p1 times random variable of x1 plus probability of p2 times random variable of x2 all the way to pn times xn. So using the same information given or the example I just read earlier, we can find our expectation because we have the random variables here, right? And then we are giving the respective probabilities here, right? So to find the expectation for electricity demand data, it is 0.2 here by 1,008 plus 0.1 plus 2,200 plus 0.35 by this plus 0.3 by this plus 0.05 times this value. The summation of them will give us 2,445, and that is our mean or expected value, right? We can also calculate our variance of a random variable given the random variable with their respective probabilities. Then we could say that the variance of the random variable is giving us the summation of I, the summation that I goes from 1 to n. We'll pick the first probability, that is pi. You multiply it by, you pick the respective probabilities one after the other. So you pick the first one, multiply it by the mean that you found, that is the expected value, minus the first random variable all squared, plus, so that's what you have here. Pick the first probability, multiply it by the mean minus the first random variable all squared. Pick the second probability, multiply it by the mean minus the second random variable all squared, all the way to this last probability and then random variable that you have. So where x bar is the expectation of the random variable. So it's simply telling you that x bar here is our expected value or our mean. Okay, standard deviation. How do you find our standard deviation when we have the variance? Note that to get your standard deviation, it is the square root of the variance that will give us standard deviation. So if you are getting the standard deviation to be 125, sorry, you're getting your variance to be 125, then we could use that information to estimate our standard deviation and say standard deviation is equal to the square root of 125, and that will give us the deviation, okay, from the mean. In practice, a smaller standard deviation implies lesser uncertainty. A larger standard deviation also implies a greater what? Uncertainty. So in small, when you have smaller standard deviation, it is just telling you that there's a less, you have the likelihood of the event occurring is lesser, right? And then you have a larger standard deviation. It also tells you that the likelihood of the event occurring is greater or is higher, right? That's what it's trying to tell you here in the note. Right. So given the same information based on the same data we had, we can use the random variables available with their respective probabilities and a mean to find our variance. So you pick the first probability, which is 0.2, multiply it by the mean or expected value that you had, minus the first random variable all squared. You pick the second probability, multiply it by the mean minus expected value, or sorry, the mean minus the random variable of the second um, that is the second unknown variable all squared. To pick the third probability, multiply it by the mean minus the fourth random variable all squared. You do the same for all the respective probabilities and random variables, and then you sum them. That should give you 292,475 as your variance. We can go ahead and use this variance value here, we have here, to find our standard deviation, as standard deviation is equal to the square root of 292,475, and we have a deviation from the mean as 450.81, or let's say 8096. Right, so this is how you estimate your variance given a probability, a random variable, and the mean, and you can go ahead and use that answer to find your standard deviation by finding the square root of the variance. Well, from here we can also calculate our coefficient of variation, or what you call covariance or risk. So what is the risk associated to the events you are working on? Right. What is the risk? If it has to do with investment, what is the risk on that investment? How risky is the investment? Is it less riskier or more riskier? So that's the coefficient of variation. To find that, it is standard deviation over the expected what value. That is standard deviation over your mean. That will give you covariance. So covariance is very useful when comparing two random variables of seemingly different scale. The covariance, in a sense, is similar to the idea of normalization, right? So the lesser the covariance, the better, right? So the higher the covariance, the higher the risk. The lesser the covariance, the lesser the risk associated to the events or the investments you are taking into consideration. Right, let's look at this example here where we have two economists. Say the economy of Ghana could be excellent, good, okay, or bad next year with the respective probabilities. 0.2, so these are the probabilities for Ghana: 0.2, 0.5, 0.2, and 0.1. The table below gives their respective returns on the investment next year. The economy here, the returns here on the investment. So let's read here. Given the second economy says the economy of the United States next year will also be excellent, good, okay, or bad, with respective probabilities and returns of 0.5, 0.3, 0.15, 0.05. And then the returns on the investment for the US economy is 10%, 3%, 1%, and 0.5%. I is saying that, or 1 says that, find the expected returns of 100,000 investments in both Ghana's economy and United States economy. Right, that's the first thing. So what are the returns on the investment? What are you getting on top of this 100,000 investment that you are making based on the economy being excellent, good, okay, and bad? So to find this first one, expected returns is just telling you that calculate the percentage of the return they've given you for the economics one after the other. So I'll pick excellent is 25. 25% of 100,000 will give me how much I'll get as returns if the economy is excellent. Same for good. 15% of the investment 100,000 will give me how much returns I'll get on the investment if the economy is good. Right. So here we can find that by going through this process. So for Ghana, I'll calculate my returns, say that the random, that will give us a random variable, right? So the random variable for excellence is just the returns of excellence by the investment. That will give you 25,000. Good. The returns when the economy is good by the investment amount, 15,000. Okay, 0.10 times, that will give us 10,000. Same for bad, it gets minus 10,000. This is giving us the random variables for the respective economic conditions, right? So here, from here, we can find the expected mean or expected value or the average. Why? We need that because of the follow-up question that we have here. So we are done with that of Ghana, that's the expected returns. We can also look at this second one. It says that quantify the risk associated with the investment. What I'm doing here is that I'm taking that of Ghana's economy. I'll take you to explain, and then you will also try your hands on the US economy, go through the same process and arrive at your covariance. So second one is saying quantify the risk associated with the investment. It is just telling you to calculate the covariance. Now, to find the covariance, we know that we need the standard deviation divided by the what? By the mean or expected value, right? So we need to find our standard deviation and then our mean before we can calculate our covariance, right? Looking at this, we can find our mean here, expected value as the summation as I goes from 1 to n. We multiply the respective probabilities one after the other by their corresponding what? Random variable xi. So here we pick the probability of for Ghana. That's the one the economy is excellent. It says that is what? It is 0.2 here. Good 0.5, okay 0.2, bad 0.0. Then what they're going to do, they're going to multiply it by their respective random variables here. So 0.2 for excellent by 25,000 random variable plus 0.5 for good by random variable 15,000, 0.2 for okay, random variable 10,000, 0.1 for bad, random variable of minus 10,000, and that will give us a mean or expected value of 13,500, right? Then we'll go ahead to calculate our, now we have the note that here we are going to calculate the risk, which is the covariance. We need our mean and standard deviation. Now we have the mean to be 13,500. We are left with the standard deviation. But to get the standard deviation, we first have to calculate for our variance. We square the variance, that gives us standard deviation, right? So looking at this next slide here, we'll say that variance is equal to the summation as I goes from 1 to n. We pick the first probability one after the other. Pick the first probability, multiply it by the mean that you calculated minus the first probability all squared plus the second probability multiplied by the mean minus the second random variable all squared plus the third probability. You multiply it by the mean minus the fourth random variable all squared, and it goes on and on and on to the final random variables and then their respective probabilities. So here you can see it here, 0.2 for Ghana by 3500, which is our mean, which is the x bar here is your mean, minus 2500, which is your random variable, all squared throughout the excellent, good, okay, and bad economy condition. And that will give you a variance of 85,250,000, right? And then the square root of the variance gives you standard deviation. So we say standard deviation is equal to the square root of the variance, and that will give us 9,233.09. Now we can find the covariance or the risk the question was asking us to calculate. It is the standard deviation over the mean, and that will give you 0.6 or 68% covariance or risk, right? That is for Ghana. So we are going to go through this same process to find the covariance for USA or United States, and then we can compare the two covariances and make a decision on that. So what do? You go by the same procedure for US, multiply the respective returns by the investment amount. So for US, the respective returns is 10%, 3%, 1%, 5% on this 100,000. And that's what we have here. 0.1 by 100,000, 10,000, 0.03 gives us 3,000, 0.01 gives us 1,000, 0.005 gives us 500. Now we can find the mean or the expected value by multiplying the respective probabilities here for US. Remember, you're doing for USA, which is 0.5, 0.3, 0.15, 0.05. And that will give us this here. 0.5 by 1,000. You have 0.3 by 3,000. You have 0.15 by 1,000. You have 0.05 by 500. That should give you 6,075 as your mean or expected value here. We can go ahead and find the variance because we need to find a covariance. Variance is equal to the summation as I goes from 1 to n. Pick the first probability. You're going to multiply it by the mean minus the first random variable squared. And if you go through that series of process that we did earlier for Ghana, you're going to arrive at the variance of United States as 159,760. Sorry, you're going to arrive at 15,956,875 as your variance. Now we can find the standard deviation by finding the square root of the variance. That will give us 3,994.61. We can go ahead and find the covariance or the risk if you invest in the US economy, right? That is standard deviation of the economy, that is US economy divided by the mean of the US economy, and that should give you 0.66 or 66% as your covariance or the risk. Looking at these two investment approaches or options, we could see that based on the covariance, we can select USA because it has a least risk, or the risk associated to investing in the US economy is lesser than that of Ghana, right? Based on their covariance. You know that Ghana had 68% risk or covariance. US is getting 66%. That is slightly better than that of Ghana. So that's US edges like Ghana slightly, right? So based on that, we can make a decision here. Which is option 3? Which country is more economically viable to invest, taking risk into account, right? So we always want to be far away from risk, right? So we'll pick the one which is less riskier. So we'll select United States because it has a less risk, or the coefficient of that is lesser than that of Ghana. Thank you for your time attending to this class or this session. I'll urge you to comment, like, and subscribe. Before we'll meet again, I'll urge you to go through this topic again, take it step by step, and I'm hoping that you get the concept